Okay, so we can always write subtraction and addition. In fact, that's not a bad idea to just convert all subtraction to addition immediately, because it can avoid making mistakes. So the original problem read b minus 2a minus c. This is not a bad idea to change it to addition, because really it's like plus a negative 2a plus a negative c. And some of you may feel that, okay, it's not really a big deal now, but for those of you that are making mistakes, this may be one of the reasons, but down the road, it definitely gets more important the more complicated these expressions get. So yeah, you can definitely do this. Not a bad idea. Always just change subtraction to addition. So there's that example. If you had another example where, I'll use a different color. So let's say you have b divided by 2 plus 16 divided by negative 3. Most of us probably prefer multiplication over division. So instead of b divided by 2, you can change all division to multiplication. Never a bad idea. So b times, what would it be? I'm going to change it to multiplication. Instead of saying b divided by 2, I can say b times 1/2, right? To divide by numbers is the same as multiplying by its reciprocal. Plus 16 times, and this would be negative 1/3. Okay. And again, you may not be necessary for a lot of you right now, because okay, it seems so simple for some of you, but it becomes more important, and again, you avoid the mistake. You avoid just making mistakes by typically, especially converting subtraction to addition. Because you make that one little mistake and you get something that the whole thing's wrong. So just be careful. Any other questions about this packet? Any other problems? Someone mentioned, I know someone was graphing. How are you guys on graphing? Good? No one has any questions? Because if you have a question, it benefits probably at least someone else in the class. Did we discuss, and this is from another class, did we discuss these concepts here? Because we watched a video that was, is 0 an even number? Did I touch on different things about 0? Okay, so let's look at this. This is from another class. But they watched the same video you guys did, where we have 0 divided by 3, 0, 0 divided by, this here is still a constant, right? Pi plus 1, still a constant, so it'll still be 0. And then one of the questions I asked, I already have it written up here, but what would be 0 divided by 0? Or anything divided by 0 is undefined, even 0 divided by 0. So just don't forget these simple things that you can tend to forget if you don't come across them or it's been a while. So anytime you divide by 0, we consider that undefined. Anyone have any questions why that's undefined? Okay. The next one, powers of 0. This is kind of interesting. I thought you go 0 to the fifth, pretty much any power of any positive power of 0 yields 0, but if you have 0 to the 0 power, we define that as 1. The simple answer for that would be, I guess mathematicians found it easier to define it this way. Then we have, did you guys ever discuss factorial? The exclamation point on your calculator? No? Okay. Let's go over that briefly. Yeah, here. So 4 factorial, what that means is 4 times 3 times 2 times 1. This is the number of ways to arrange 4 books on a bookshelf. There's 24 ways to arrange 4 books on a bookshelf. 3 factorial, 3 times 2 times 1. And this would be what's called a permutation. And we might discuss this briefly. It's just basic statistics, basic probability. But let's say you have 4 items to arrange, whether it be books or people in a line, and you want to use all 4. So you have 4 to choose from, and you're taking 4. You would just simply do 4 factorial. So then point out here, 1 factorial is 1, but what is 0 factorial? You would also say is 1. And the way to think about this is if you have 0 items to choose from, and you're taking all of those items, which there are none of them, how many possible ways can you arrange those items? 1. You just be a blank, like a blank bookshelf, for example. And so we define that as 1. This is a good review for you guys, I think. Yeah, simplifying radicals. Guys, probably some of you guys forget this, or you maybe never weren't taught this way. But I think the best way to do these, this one you might know off the top of your head. This is a nice rational value too. But what about the square root of 8? The square root of 8 is not. It's gonna be irrational. But how do you do it? So with 8, we're going to what's called prime factorized. Have any of you heard that, prime factorization? Does it sound familiar? So it gets its name for a reason, because you're breaking something down into its prime components. So the question you ask yourself when you want to prime factorize is, say, what's the smallest prime number that goes in 8? Well, what's the smallest prime number, period? What's the smallest prime number? Not 1. It's 2. And it's 2 because the way we define a prime number is has exactly 2 unique whole factors. So 1 only has 1 factor, one unique factor. 1 times 1 is 1. But 2 is the smallest. Let's see if you guys remember. If we make a list, it's good to probably know the first so many. So 2 is a prime number. What are some other prime numbers? Probably ascending. You guys know prime numbers? I'm assuming prime numbers you discussed, like algebra, pre-algebra, yes? Yes, no? I know it's early, but anyone know like the next smallest prime number? 3, thank you. The next one? Thank you. 9 is not prime, because 9 has 1, 3, and 9 as factors. 11. Which one? 17, thank you. And there's an infinite number of them, but here's the first few. You probably just kind of know at least up to 19. What's great about this is that you can break down any number very quickly. So here's 8's pretty quick, right? Okay, 2 times 4, and 4 breaks down into 2 and 2. But this is very useful for when you have someone give me a fairly large number. 537. Okay, so hopefully this is not a prime number, otherwise I'm going to be like, it's going to be a while. Now I immediately know it's not prime because, first off, it's not even, right? So 2 is not, so again, the repeating question, you guys might want to write this in your notes when doing this, is what is the smallest prime number that can go into this number? So 2 can't, right? 2 is the smallest. Okay, what's the next smallest prime number? 3. How do you know if a number is divisible by 3? What's a quick way to know if this is a multiple of 3? You guys remember the rule, the trick? Anyone? It's the same rule for 9, and that is if you add up the digits, 5 plus 3 plus 7, if that number is divisible by 3 or a multiple of 3, then this number is a multiple of 3. So 5 plus 3 plus 7 is 15. 15 is multiple, so this is divisible by 3. So 5, 3, 7 divided by 3 is going to be what? 1, 23, 7, 1, 27. I think someone could take that 5 by 8, 179. anyone knows the calculator on the table. So 537 is 3 and 179. Check that for me. And now 179, this might be prime, I don't know, because 3 is not going to work. So we have 16, 17, so 3 doesn't work, 2 doesn't work, of course. Once you go past, by the way, 2 will never work again. Okay, if 3 doesn't work for this guy, 3 will never work again down this tree that we're making here. So 3 doesn't work. So what's the next smallest prime number? 5. Now this is when it's handy. It is nice to have a calculator. Okay. So 179, is that a multiple of 5? No, because it doesn't end in a 5 or a 0, right? Next smallest prime number 7. Someone figure out if this is a multiple of 7, please. It's not. Okay. 8, 9, 10, 11. 179 divided by 11. What do you get? What do you get? Okay, so 16 and change. Once we cross over, so see I have 11 and 16 and change. Once we cross over in terms of our testing factor, once that exceeds what the other factor would be to make up that product, you can stop. So the next smallest prime number is 13. Can you check 13 for me? $13 and change. So you know the next test that you're going to do, which is going to be 17, that's going to exceed what would be the other factor to make that product, so you can stop. So this breaks down into 3 and 179. So if you, for example, if you had the square root of 537, you could not write this any more perfectly than the way it's written right now. This is the most perfect way to write this. Decimal form is going to be, because it's irrational, it's going to be non-terminating and non-repeating, just like pi is irrational, non-terminating, non-repeating. So I want you to understand, I don't know if this was ever made clear to you by any of your teachers, but this, you cannot write this any more simple. There's no more perfect way to write this number than the way it's written. Does anyone have any questions? Doesn't know what I'm saying when I say that. It doesn't simplify. So let's look at something that definitely would break down, and I want you to see it break down very quickly. Computers is a good example. You ever wondered why when you get an iPhone or an iPod or pretty much any sort of device, it's like, okay, it advertises that it's, let's say, 128 gigs or 64 gigs. Say 64 gigs, but the actual formatted capacity is, I don't know, 59 point something gigabytes. If you ever wonder why that is, this is why that is. Because their basing data is based on binary. There's actually 1,028 bytes in a kilobyte, not 1,000. And there's 1,028 megabytes, or 1,028 kilobytes in a megabyte, 1,028 megabytes in a gigabyte, 1,028 gigabytes in a terabyte. So that's why, let's say if you buy a terabyte external hard drive, it's going to be like significantly less actual format capacity. Because what they're advertising is, oh, we're going to advertise that there's 1,000 bytes in a kilobyte, and there's 1,000 kilobytes in a gigabyte. But that's not what actually it is, because, watch this, because 1,028, if you break this down, so let's say you had to find the square root of 1,028, okay? Fairly large number, but with a calculator, let's go ahead and break down 1,028. In fact, to be as least confusing as possible, I'm going to write it off separately so that guy remains like that. So let's go ahead and break down 1,028. Prime factorization, smallest prime number is 2. 514. Then I did this wrong, so 5,016 I think is what it should be. Wait, I think it's 1028. We'll see. So 514. We'll just do this one anyway. So we'll see. And then do it again. So 2 again, right? Because it's even. What do you get?
257.
257. Yeah, I did it wrong. Okay, so now we're here, but that's okay. Let's do this one. So 257. Is that a multiple of 2? No, it's even, or it's odd. What about 3? 2 plus 5 is 7, plus 7 is 14. 14 is not a multiple of 3, so 3 doesn't work. 5 doesn't work. Someone try out 7 on a calculator. What? 36 and change. Okay, so that doesn't work. We need nice, perfect numbers. 8, 9, 10, 11. What's the other guy? 11. What's the other guy?
11.
Yeah, what's the 11 and what? So 257 divided by 11 gives you what?
Oh, 23.
23 and change, okay. 13. 19 and change, and then finally probably 17 is what's going to break it, in terms of we can just stop. 17 you break. Yeah, so this square root of 1028. This is probably, in my brain, this is probably coming from when you buy a television. Or that's 1080. I don't know where this is coming from. It's too early for math. But this does break down, so you can now do this. Have you guys ever done this? Raise your hand if you've ever done this before. Okay, so only maybe less than half of you have done this. Okay, so I'm glad I'm going over this. So, because the square root, right, the index is understood to be 2, even if it's not written. We don't have to write it, but because it's 2, we're going to take out pairs of numbers. Oops, I'm doing that. We're going to take out pairs of numbers. So here is a pair of 2's. So we can take that out. And what's left over, what's left as the radicand, is the guy that couldn't break down any further. And that'd be 257. So I circled a pair because the index is 2. If there were any other index larger, like a 3, 4, 5, whatever, this guy could not be written any more simple because I couldn't take out a set of 2's. So I think it's a 516. 1024. Yeah, 1024 is the one that I wanted to show you. Sorry. So there's actually 1,024 bytes in a kilobyte, and same going up. So let's say you had to do this square root of 1,024. So breaking this down, we have 2 and 5, 12, 2 and 256. 2 and 128, 2 and 64. I want to continue over here. 64 and breaks down into 2 and 32, 32 and 16, 2 and 8, 2 and 4, 2 and 2. So there are 1,024 bytes in a kilobyte. So here, because it's the square root, I'm going to circle pairs of 2's. 64 continued here. And there's none left over. So the square root of 1,024 is going to be 2 times 2 times 2 times 2 times 2. So what is that? 2 to the 1, 2, 3, 4, 5, 2 to the 5th power. Which is what, 32? So 32 squared should give you 1,024. So, I think the bell's about to ring. If this were a 3, you would circle sets of 2's. So this works no matter what the index is. That's what's really nice about prime factorization. Any questions? Okay. Go ahead and turn in this. Does anyone plan to finish this? Okay, then you turn in. You can work on it and turn it in. We'll go over it tomorrow some more for each.